Welcome, everyone. My name is Victor Monga, and this session is Introduction to Zeek. I think we have a cool name. We call it Zeek and You Shall Find. That's what the series is. Our speaker here today is Fatima, and Fatima is a security engineer at University of Delaware. She is very involved with nonprofit organizations. She is part of a couple of boards, and her motivation, determination is giving back to the community, how to actually bring the education delivered to those who need it. She holds also a couple of certifications such as CISSP, and from SANS, she has intrusion analysis, incident handling, and penetration testing. This recording is going to be uploaded to YouTube, or the slides will be available on LinkedIn. So if you don't mind following us, and you should be able to access all of that. Once again, my name is Victor Monga. We are presenting from Varsity Testing. I'm going to hand it off to our speaker today, Fatima. All yours.
Alrighty, perfect. Thank you so much, Victor, for the introduction. Hi, everyone. Good evening, good morning, good afternoon, based on your time zones. And we will just deep dive into the Zeek now. So yeah, this, as Victor said, this presentation is primarily for the introduction to Zeek and getting to know a little bit more about what Zeek is and what are its capabilities. So a quick run through on what we are going to touch base in today's webinar. We are going to talk about what exactly Zeek NSM is, some history and background of Zeek. And I have it there, bro, because it actually got renamed recently in 2018. In October, in BroCon of 2018, they renamed the project from Bro Ideas to Zeek Ideas. So that's why I have it in the first line as struck out. We will go over some of the uses of Zeek, some of the log files that Zeek generates, and we will be just touching the surface on the logging part. And then there are a lot of frameworks that Zeek has, but we will be just going over one of the very important framework that Zeek is based off of. And then lastly, I will have some appendix slides where you can actually see some of the quick picks from the logs that you can use Zeek for, and right out of the bat value of running and installing Zeek in your network. So starting with what is Zeek? Zeek basically is a network security monitoring system. It is a passive scanner. So what it does is it sniffs the traffic on the network traffic links, and it then generates a lot of log files based on what it has seen on the network. So that's why I have it as NSM, because I like to call it a network security monitoring tool rather than an IDS, which is intrusion detection system. People might confuse and misuse those two terms interchangeably, and they should not be used interchangeably, but that's why I'm very specific in mentioning Zeek as an NSM. So yeah, all it does is it sits on your network. It's a passive scanner tool. It scans, or it holistically scans all the traffic and all the packets that are going on the wire, and then it generates all the log files based on whatever protocol it has seen on your traffic. So it just basically gives a holistic view to a network security engineer or a security analyst, and just to give a background of what has transpired on the wire during that period of time, and what are all the log files and what are all the protocols that it has seen during that particular period of time on your network. Some history and background. So the name Bro was originally coined for this NSM system. Actually, it came from a novel. It was a very famous novel, 1984. I haven't read it, but there is a reference in that novel, and there's a character, George Orwell's. He is known as Big Brother in that novel, and his role is basically he's kind of like a big brother who looks after all the people of the community. So that was kind of like a background. So when Warren started writing the code for Zeek in 1994, he actually coined the term Bro, in sense that Bro is like a big brother on your network, and it sees all the network traffic that transpires on your network. So that's why the name came about as Bro, and until 2018, it got renamed to Zeek IDS system. Zeek Network Security Monitoring System. It has been managed by a vast community since 1994. It has been supported and managed by like more than 20 to 30 developers and users all around the world. And that's the important point, right? That in an open source project, it's very important that how well maintained it is and how much people are contributing back to it. And it has more than 50 different protocol parsers. Definitely it has more than 50 because it basically logs everything on the basis of what it has seen on the application layer, like what application layer protocol it has seen on your traffic, and then it creates the log files based on that protocol. So so it can create more than 50 different log files. Apart from the traditional log files, traditional protocol log files, it has some other interesting log files as well that we will go into detail in coming up slides. But this is the basic history and background of why the project got named as Bro, and then recently it got renamed from Bro to Zeek, and it has its own story that a lot of like when they started BroCon, and when people started getting the permissions from their managers and bosses, and they would say that we are going to BroCon, Bro has a different connotation to it, and it's a little weird connotation, so people would not think of it as a intrusion detection or a security monitoring tool. So that's why they were like that we should change the name to something that would more reflect on the functionality of the tool rather than having a different weird connotation. So that's why the whole Bro renaming happened in 2018. Why use Zeek? So first and foremost, it's an open source and free tool, and it has like vast community support, and you don't need any kind of specialized tools or equipments to run it. So you just need the Linux boxes, and it would just run on top of that efficiently. It's a very powerful network analysis and monitoring framework. As I said, that it is a network security monitoring tool that keeps an eye on your network traffic all the time, and it generates user-friendly logs for an analyst or for a security engineer to look later on in the time, that if I want to go back in time and see that what has happened during this time period of day and what protocols were transpiring on my network, I can absolutely go back to that time and see what all log files were generated by Zeek. So that is one of the best features I like about Zeek, is the flat files it generates. Like, you don't need an additional tool to parse those log files to be able to see that. For example, if you have PCAPs, you just cannot do a less or grep or a more on a PCAP. You need either a T-Shark or a Wireshark to open up that PCAP, and then you have to filter out the protocol that you are interested in looking at. Like if you want to use, if you want to see DNS traffic, or if you want to see HTTP traffic or SSL traffic, you have to like write all sorts of filters in Wireshark to get that specific kind of traffic. But in Zeek, it generates all the log files in flat ASCII format. It's tab separated, so you can absolutely do all sorts of command line kung fu. Like you can do grep, sort, awk, any kind of filtering on the log files. And at the same time, since it's tab separated, all the log files are easily ingestible in any kind of a log processing engine that you have, like a SIEM solution or a normal logging tool that just can ingest any kind of formatted file. So in this case, tab formatted. So yeah, so those were the basic key points that would be interested in anyone, that would be interested for anyone to be able to run Zeek. Zeek has a lot of different frameworks. Like it has more than 10 different frameworks that are very important, but the crux of all the framework is the scripting framework, because Zeek is based on the scripts. Like it runs on all the scripts that it ships with. So the scripts are actually spread out. So when you have Zeek installed and when you run Zeek, you find 3 different folders where you can find the scripts. So how can you find that whether this is a Zeek script or something else? So all the Zeek scripts are ended with the .zeek. It used to be .bro, but now it's .zeek suffix. So all the scripts that are in base folder, that will be like ssl.zeek or http.zeek file, Zeek scripts. So all those scripts are by default loaded. So when I said that when I said that Zeek has more than 50 different protocol parsers, I meant that there were scripts written in the base folder that would analyze and parse those protocol traffic and log that traffic in the log files. So 3 important directory locations that you need to keep in mind. One is the base. Yeah, go ahead.
Sorry to interrupt you. We have a question. So one of the question is that if someone doesn't have scripting knowledge or experience, can they still use Zeek?
Absolutely. You don't have to do anything. It's like out of the box. So as I said, that it comes with its own scripts, and the bare minimum scripts that Zeek requires to run are in the base folder. You don't have to touch them. They come with script. But if you want to customize, or if you want to write a signature by yourself to detect something really cool that you want to detect in your network traffic, then you have to write scripts and load them in Zeek to detect that specific kind of traffic that you want it to detect. So you don't have to do anything with scripting a framework, or you don't have to write custom scripts for getting Zeek started in your network. So if that answers the question. Okay, I'll move along. So the policy folder and the site folder. So the site folder is the folder where all the local configuration resides. So there is a local file called local.zeek that is in the site folder, where you define what scripts you want to load, or what scripts you do not want Zeek to load by default. So if you have some custom scripts that you have written, you can go into site directory and you can load them using @load statements in local.zeek file. Policy directory has all the Zeek policies that it comes with and that are enabled by default. So how it is different than the base script is the policy script. The policy directory has the scripts that can detect additional stuff on top of the bare minimum Zeek running. For example, the scanning detection, or SQL injection detection, HTTP brute forcing, SSH brute forcing. So all these scripts are written by Zeek developers that they ship in policy folder in Zeek, so that you get a chance to enable or disable them in the local.zeek file. So these are the three basic folders where the Zeek scripts reside, and you don't have to muck around the base folder, but policy and site are the folders where you can actually enable and disable the scripts. Zeek logs. So there will be hopefully one whole session on just analyzing Zeek logs. But just to give you an overview, when I said that Zeek generates a lot of log files, just to give you an overview that what those log files are. So the conventional log files are based on the name of the protocol. So http.log will have all the traffic on your network that Zeek saw as HTTP. SSH.log will have all the traffic that was corresponding to the SSH connections. The DNS.log will have all the DNS related traffic, and the connection.log is a generic connection file that keeps track of all the connections Zeek has seen on your network during that period of time. And then there are many more. As I said, that there are more than 50 different protocol parsers. There are more than 50 different kinds of log files that gets generated in Zeek. So apart from the conventional log files, there are some very interesting log files that exclusively Zeek generates for the security analysts and security engineers to look at. So my favorites are the notice and intel.log file. And I have in appendix some of the things that we just do command line grep on notice.log and intel.log to search for bad actors. And I will go into the details in coming up slides. Software.log file logs the different kind of software that Bro finds in the network traffic. So a lot of times there are browser plugins that advertise themselves that, oh, I'm plugin, I'm SQL plugin, or I'm PHP plugin, and my version number is this. So usually when these plugins communicate back to their servers to get updates, they leak out a lot of data in that transaction, and Zeek keeps a record of that, and then Zeek logs that data in the software.log file, telling you that these are the different kind of plugins, different kind of browsers, and different kind of operating systems I have seen on your network. So that is pretty interesting. Notice.log file will have all the notices that you would want to take a look at. Like, for example, if Zeek has detected a scanner on your network, it will log it in the notice.log file. If Zeek has detected an SSH brute forcer attack, it will log it in the notice.log file. So other things that requires the notice of analyst gets logged in notice.log file. Intel.log is another one of very important log files that I love, and that only gets generated if you have Intel framework enabled in Zeek. So we will have another series on different frameworks, and Intel framework basically allows you to load the IOCs. IOCs are the indicators of compromises. So if you get a feed of IOCs from, say, a commercial provider, and if you have like top 1,000 bad IPs or top 1,000 bad domains or certificates or hashes, you can take all that data, all the IOC data, and you can load it in Zeek and tell Zeek that whenever you see these IOCs in my network, log them in intel.log file. So that file will not get generated right out of the bat, but if you have Intel framework enabled, then that file will get generated if you have IOCs loaded in Zeek.
Fatima, here's another question.
Yeah.
What is an IoT?
IOC is indicator of compromises. So what happens that when somebody gets breached and when somebody notices a bad IP address that is trying to brute force them, people share that data in the community that, oh, this is an IP address which is bad, and this IP address is scanning us, or this IP address belongs to Shodan, and this IP address is a attacker's IP address. So there are people out there who are the open source providers who collect that bad data, and they tag that bad data as IOC, which is indicators of compromise. So that data is collected by different people who have provided that data saying that I'm confident that this IP is bad. So all the collection of that kind of data, it can be domains, it can be bad domains or the phishing domains that people have reported to Google. It may be the bad IPs that people have reported. It may be the bad certificate hashes that people have reported, or maybe bad file hashes that, okay, this is the hash for Eternal Blue malware, or this is a hash for this XYZ malware. So these are called indicator of compromises that get shared around the community. And you can get a lot of providers for IOCs. If you just search for how can I get the indicator of compromises, like bad IPs or domains, Spamhaus and Fishtank has all the list of bad domains that they have seen. So you can just pull that down, load it in Zeek, and tell Zeek that whenever you see these bad actors in my network, just let me know. And that let me know will be in intel.log file. The other two files that are curious and important to me are known services and weird. So known services.log is very important. So what Zeek does is whenever it sees a connection from an HTTP server or any server that is in your network, it keeps track of that and it logs it in the known services.log file. So if you want to enumerate that how many DNS servers I have, or how many clients on my network are acting as DNS servers, you can absolutely go through the known services.log file to see the holistic view of what all services are provided by your network, like what all services internet is seeing on your network. So that's pretty important log file. So where should I start? So a lot of time when people know a little bit about Zeek, they get confused that there are so many different portals. People have written their own blog post and there are like 50 different articles with 50 different steps. So where should I start? So there's a very, so I would suggest to follow the official Zeek document, read the docs. They have a great documentation on getting started on Zeek, and they have tutorials and they have documentation on how you can install Zeek in standalone mode as well as in a cluster mode. So for big institutions and big organizations who want to run Zeek in a cluster environment where they need multiple servers to run as a cluster, they have everything written down. So the first link on the site, the first link on the page that you see is the installation guide. So you just go to the docs.zeek.org, and then in that installation page, usually Zeek only runs on the Unix systems. So it has Linux or CentOS or any flavor of Unix you can run Zeek on. So it has proper installation guide on whether you want to compile it from source, and whether you want to do it via yum update or apt-get install. So they provide both binary packets as well as source. So that is the absolute guide I would recommend to go over to spin up a Zeek installation instance in your environment. Second one is the quick start. So once you have Zeek installed, it creates different directories in the default path. So the quick start guides shows you the steps that are required, or the minimum configuration that is required to have Zeek up and running, and testing scripts and modules. So if you're interested in writing your own custom scripts, there's a great website called try.zeek.org. So it gives you an interface where they have Zeek running on their server. They give you a web UI where you can type in your script and test that script on their Zeek instance on their server. So you don't even have to go through the trouble of installing and making it run on your instance if you want to test it. So for just testing purposes, you can absolutely try Zeek you can absolutely try.zeek.org. I use it all the time. So whenever I want to write a custom script, I don't test it on my production cluster. I just copy paste that script on try.zeek.org, run it there, and see if I see any errors on that server. So that's highly recommended website to go to if you want to learn more about Zeek. It also has small Hello World programs, not programs, Hello World scripts that actually shows you how to use a if loop, or how to use a for loop, or if else conditional statements. So I would highly recommend that. And we would cover that. So this introduction doesn't cover that part, but all these 3 steps that are shown on this slide will absolutely be covered in coming up webinars in this series, in this Zeek learning series, if people would like to go into more deep dive into how to do things with Zeek. So another question, so far we have covered like what is Zeek, why to use it, what was the little bit of background of Zeek, what was the history, how can I get started? And once you have all these questions answered, like once you have Zeek up and running, the next question I always get from the users are, okay, so now I have Zeek running, so now what should I do? I'm not seeing any alerts, I'm not seeing anyone attacking us. So this is a very generic misconception that people have, that if you will run Zeek, all of a sudden it will find all this different cool stuff in your network. That is not true. And that's why at the very beginning, when I said that people confuse IDS with NSM, and I specifically use NSM in Zeek context, is that this is the difference. Like if you have Snore or Suricata, they are signature-based engines. People all the time write the signatures to detect different kind of attacks. So that's why it's considerate to call them as intrusion detection system. However, Zeek is more than that. Zeek not only detects cool stuff for you if you have scripts enabled, but also it gives you a holistic view of the network. So right out of the bat value. So as I mentioned, that Notice and Intel framework are the go-to frameworks that I started playing around with when I started with Zeek here. So when I had the same question that, okay, I have Zeek and I have to improve on its functionality and I have to make it do stuff for me. So we start, and you don't have to write everything from the scratch. Like when I say custom scripts, there's a whole bunch of community out there who has written so many scripts in over like last 25 years. So you don't even have to write script by your own. You just have to copy paste it. You have to just take the script, load it in your Zeek, and then see if it detects that kind of stuff. And the recent example is this CVE that got released, the 0601 CVE. That was the Windows vulnerability of the keys, the certificates, and it was a 0 day, and the very next day, in like few hours, there was a script available in CoreLight community that was shared, that if you are running Zeek, this is the script you want to load to detect that vulnerability. So that was pretty awesome that people are actively writing those scripts to detect things. So you don't even have to learn scripting to get any script installed in your cluster. So that was the thing I wanted to mention, that people have misconception that, okay, I have to be very pro with Zeek scripting, and if I don't know Zeek scripting, I would not be able to use it. That's not true. 90% of our Zeek scripts are taken and stolen from the net. So I have copy pasted all the scripts that are available, and people have written it for a reason, right? People have written it for you to use it. So ScanNG is a very famous package that is written by one of my friends who is in Lawrence Berkeley National Lab, and that package detects all sorts of scanners on your network. So that is pretty awesome. So once you have that package installed and enabled, it will detect all kind of scanning attempts on your network, like port scan, address scan, knock-knock scan, low port throttling, every kind of scan. SSH and HTTP brute forces. So the interesting thing is the second bullet point here, the SSH, HTTP brute forces and SQL injection attacks, there are built-in scripts in policy folder that Zeek comes with that are enabled by default, and those scripts detect those kind of attackers. We will go into those logs in the appendix section, and I will show you what I mean by detecting scanners and brute forcers. Detect high confidence IOCs. So for that, you need to enable Intel framework. And as I was mentioning before, that IOCs are indicator of compromises. Basically, you take down the blacklisted IPs, blacklisted domains, phishing domains that has reported to Google, etc. And they are all publicly available. There are a whole bunch of websites that provide open source free IOCs for people to use. you can pull them down, install it in Zeek, and intel.log will get generated and block some weird activity. So there's a really cool file, weird.log, that gets generated in Zeek, and it keeps track of all the weirdness of your network. So that is pretty awesome as well. And some kung fu on the command line. So you can grep through a lot of different keywords or some lot of different names or keywords if you think that they might be appearing in your log, and you can see that, oh, am I seeing Nessus scanner in my logs, or am I seeing this scanner in my logs? So you can do that with different kind of scanners. Some advanced use cases. These are the use cases that are for people who have Zeek up and running for some years and have some little bit of experience in dealing with how they can use logs. So these are the use cases that we use Zeek for all the time here at university. We detect a lot of firewall misconfigurations. Every now and then we detect a lot of firewall misconfigurations using Zeek logs, and especially the known services.log file that I was mentioning, that it shows you your attack surface, that just like Shodan, just like you go to Shodan and you type in your CIDR, like subnet ranges, the IP ranges, and it will show you that, oh, you have like 50 RDP servers open, you have 80 HTTP server open, you have 90 SSH server open, and XYZ. So that's the thing that you can actually take advantage of in Zeek, that it generates known services.log file that you can absolutely use to narrow down or shrink the surface, the attack surface that is exposed to the internet. Enumerating servers and services, again, the same file can be used. So a lot of times we get a question from the higher up that, oh, do you know how many DNS servers we have open to the internet? Because this is like a DNS attack that is impacting different organizations. So just out of curiosity to know that what is our attack surface and how it looks like. So we get these kind of questions all the time, that how many HTTP servers do we have, or how many SSH servers do we have that are open to the internet or that are exposed to the internet. And all I do is I just go in our Zeek log file, I see known services.log, and I grab through HTTP, and it shows me all the IP addresses that is talking HTTP, talking HTTP on the internet. So that is pretty awesome. And policy compliance. So the software.log file that I was talking about, that it keeps track of all the software it has seen on your network. It contains operating system versions as well. So you can see Windows operating system versions. You can see different Mac operating system versions. So it is useful, right? If you have an organization that has a policy compliance saying that Windows 7 now is end of life. In this beginning of this month, Windows 7 went end of life. So you should not be running Windows 7 anymore. So how you can detect that? You can detect that using software.log file. And you can grab through all the IP addresses that are showing that they are still running Windows 7 operating system. So you can use those log files for the policy compliance purposes as well. Again, malware detection, one of the very basic use cases. Whenever we get some infection notices from our clients and we suspect that something suspicious is going on, our first absolute resort is Zeek logs, because it gives you a holistic view of what has happened and how much traffic was transpired on the network during that period of time from that client IP. And know what's on your network. As I said, that in general, it has open ports, site open ports.log file, known services.log file. So you can actually get an estimate of all the assets you have on your network that are open to internet and that are exposed to internet. So these are some advanced use cases, but they're highly simple. Like, you don't need any kind of specialized scripts or anything to detect that. It's just like, when you keep analyzing the logs, you will start getting these kind of ideas for implementation. So, and as I mentioned before, that I have appendix slides that would show you what exactly I mean by quick wins. So this is the first appendix slide, which shows the scanners. So these are all taken from the production cluster. So nothing here is dummy, all is real world traffic. The first column is the very big string you see, that is epoch time. So by default, Zeek logs everything in a timestamp format called epoch, which is Linux timestamp, if you guys are familiar with. So the first column is the timestamp, and then the scan : knock scan. This is the notice type that got alerted. The third column is the IP address. So what all Zeek is saying in these three attempts is it is saying that the first IP, the 200.168.123.62, it has attempted almost more than 12 host scanning attempts on at least port 8080. So, and these are getting generated by the scan ng scripts that we have loaded, and they all will be shown in notice.log file. So the second one is the backscatter scan attack. 42.188.239.15 IP. That IP was trying to scan or trying to do a backscatter scan attempt on 10 different ports. And as you see, it was a very basic address scan from another IP that scanned at least 30 hosts on that port. So that was pretty neat. And we take direct actions. We don't like do a compromise that, okay, we are getting alerts, but what to do about it? We take these IP addresses and we directly block them on our network. If we see the notices from the Zeek saying these are the scanners, we absolutely block them. The second one is again from notice.log file, and it is showing the HTTP basic auth brute forcer notice type, and it is showing that IP 45.248.87.145 has 64 failed login attempts on one HTTP auth server. And it shows a timestamp as well, that it was recorded in almost 1 millisecond. So nobody's that fast, right? And it shows that it was an automated attack, because nobody can have 64 different kind of logins in 1 millisecond on one server. So, and these three, the SQL injection, attacker, and password guessing, I didn't do anything. These scripts come with Zeek and they're by default enabled. So if someone is trying to brute force on your network, or somebody is trying the SQL injection attacks on your network, or if somebody's trying SSH password guessing on your network, these logs will show up in your notice.log. You just have to grep through these notices to look for and those IP addresses, and then you can take any action you want. Like you can blacklist those IPs on your network, or you can block them on your network, and then see what other activities these IPs are doing on your network. Anything you can do after that. And this is the second slide where I wanted to show some quick wins. So the first one is the Intel IOCs, intel.log file. And as I mentioned, for that to get enabled, you need to have Intel framework enabled in Zeek. So all that log is showing is the first column is the timestamp. The second column is the unique identifier for that connection. Zeek keeps track of all the connections with the unique identifier. The third is the source IP, source port, destination IP, not destination IP and destination port. And I have deducted it because, as I said, it's all from production logs. So that's why I had to deduct all the destination IPs, because they are real IP addresses. And it says that the bold one, the red bold one, 89.248, this is the bad IP. And what Zeek is telling us that it has seen this IP, which is Intel address, which is the IOC type IPv4 address. It has 85% confidence that it's bad, and it was reported as scanner or honeynet or an SSH scanner by people. So when you have these IOCs loaded in your Intel framework, these are kind of like logs you will get. If there is an IP hit in your traffic, it will have the IP log. If there is a domain or DNS hit, then this IP will be changed to the domain name, and then Intel address will be Intel domain. So that's pretty cool. And we block these bad IP addresses altogether on our network. We don't allow them to talk either inbound or outbound from our network. I was mentioning a lot about weird.log file. So bad ICMP checksum. So whenever Zeek sees weird activity going on the network, it logs it in weird.log file. And I have only shown bad ICMP checksum because that is the one we actually take action on. We kind of like log the IP addresses for which Zeek has reported as bad ICMP checksum. Command line kung fu. So right off the bat, an http.log file, if you just grep on OpenVAS, or if you just look for the ZMEU, these are the two very famous scanners, and they don't even change the user agent that they use for scanning. So the first attempt is coming from the OpenVAS, and the Mozilla /5.0 is the user agent it is using. And the second attempt is a very famous European scanner called ZMEU, and that attempt is coming from their scanning. Fake Google bots. So this was a very interesting find. So this is again notice.log file. It was detected as scan web crawler, and the IP address was 217.208. And it was using Googlebot as user agent. So the legit Google bots that Google uses to crawl the websites, it has very specific properties. First off, the IP ranges are different and they are all owned by Google. And second, the DNS names of those IP addresses always ends in DNS.google.com. So you can see that this IP address is faking to be a Google bot because that IP address's DNS name ends in telia.com, and that IP address is not in the range of Google's IP address range for scanning the web. So you can absolutely block those kind of fake scanners who pretend to be Google bot, but they're actually not Google bot. So what's next? So this is all I had for today's introduction webinar on Zeek. And as I said, that there are so many things in Zeek that needs to be learned and needs to have hands-on activities. So these are some of the next hands-on and learning activities that we are planning in this learning series of Introduction to Zeek. And for the hands-on installation configuration would be the next, like I would actually run the VM where we would be able to install and configure Zeek in bare minimum configuration to have it run standalone. Scripting framework, how to write Zeek scripts. I will be touch basing on how you can write basic scripts, and then from there, how can you move forward. And logging framework, again, it takes a whole class or whole hour to explain how good the logging framework is in Zeek, and all the logs that it already creates for you or already generates for you, and all the custom logs that you want Zeek to generate for you. And the learning series will be advanced use cases of Zeek. So I just brushed through some of the advanced use cases that we have, that we had experienced in past, but these will deep dive more into how you can use Zeek in real world traffic, and then some deep dive into the log file analysis as well. Because I didn't go over the log files, how they look like. So I would like to show you how different log files look like and how you can correlate things based on different log files that Zeek generates. So this was all, this is all planned for this web series. And yeah, and let us know if you would like to learn anything else apart from these hands-on and learning series. We would be happy to do so. So that was the wrap.
One of the things, Fatima, we have one of our attendees been asking if Raspberry Pi.
Oh, Raspberry Pi. Okay, I'll write it down.
So we can look at it if that's something audience would like to see it. We can also look at in our Kubernetes series that we could do probably on Kubernetes or K3s or Docker. So definitely we'll look at it.
All right.
We all appreciate this feedback. This helps us improve this series, and this also helps us understand if you guys want to see something else in this teaching webinar series.
All righty. Any other questions we have?
That's what we have. Anything else? If you guys feel like, if you think about it, you can always contact us at contact@virtuallytesting.com. Please mention the question in the subject line and provide a detail in your body of the email. We'll definitely get back to you.
All righty. Well, thank you so much, everyone, for your time and attending and listening to this webinar. I hope that was useful, and I hope there are some takeaways that you can take from this webinar and can implement it or apply it in your Zeek clusters installations.
So attendees who are listening to this webinar, if you are in LA area and would like to get a free pass to FutureCon, it is happening on February 19th, 2020, downtown LA. It will start at 8 a.m. and it will end 6 p.m. Very, very informational cybersecurity conference. A lot of great speakers have lined up already. If you just go to this URL, futurecon.virtuallytesting.com, and if you feel like you want to attend it, you can use the promo code FutureVT20, as it's shown on the screen right now, and you will get a free pass to this conference. We can go to the next slide from here. We'll upload the slides to our LinkedIn, Twitter, and this recording will be available on YouTube. So if you guys want to go back and review this webinar, you can do so. Once again, thank you all for joining. Thank you, Fatima. It was a really great session. Thank you.
Oh, thanks, Victor. Thank you, everyone, for listening in.